Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square minus 1 into y equals to x sine 3x plus cos x. So firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so our order will be 2. And highest power of the highest derivative is a degree is 1. Right? Or just write the given differential equation as d square y minus y equals to x sine 3x plus cos x. We know that d is a differential operator. The d square will be d square by dx square. Now our equation becomes d square y by dx square minus y equals to x sine 3x plus cos x. Here d square y by dx square is the highest derivative, so our order will be 2, and highest power of the highest derivative is a degree is 1. Now coming to the problem. Given differential equation, d square minus 1 into y equals to x sine 3x plus cos x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 1 and q is x sine 3x plus cos x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get the homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. So now let's find yc and yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 1, right? Let's replace differential operator by m, so that we'll get f of m equals to m square minus 1. Then our auxiliary equation becomes m square minus 1 equals to 0. We can write this 1 as 1 square, then we'll get m square minus 1 square equals to 0, which is of a square minus b square form. So we can write it as m plus 1 into m minus 1. Now equate each factor to 0. From m plus 1 equals to 0, we'll get m equals to minus 1. From m minus 1 equals to 0, we'll get m equals to 1, right? So here the roots are minus 1 and 1. So m equals to minus 1, 1 are the roots of our auxiliary equation, which are real and distinct, or we can call them as real and different, right? Therefore, m equals to minus 1 plus 1 are the roots of our auxiliary equation, which are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then yc will be c1 into e power 1 root into x plus c2 into e power another root into x. Now, let's write our complementary function. Yc equals to c1, one constant into e power 1 root into x plus another constant into e power another root into x. Then yc equals to c1 e power minus x plus c2 e power x. So we got yc. Let's find yp now. Particular integral We'll find particular integral using 1 by f of d into q. We have f of d and q, where f of d is d square minus 1 and q is x sine 3x plus cos x, right? We can write this as 1 by d square minus 1 into x sine 3x plus 1 by d square minus 1 into cos x. So this is of 1 by f of d into x into v form, and second term is of 1 by f of d into cos ax form, right? So let's find each term separately. Firstly, we are going to find 1 by f of d into x sine 3x, right? So this is of 1 by f of d into x into v form. So here we are going to use the formula x into 1 by f of d into v minus f dash of d by f of d whole square into v, right? Is equals to x into 1 by d square minus 1 into sine 3x minus, if f of d is d square minus 1, then f dash of d is 2d minus 0, which is 2d, right? So we'll get 2d by d square minus 1 whole square into sine 3x, right? Now, just compare 1 by f of d into sine 3x with 1 by f of d into sine x. So for a equals to 3, we'll find d square, which is given by minus of a square. This is equals to minus of 3 square equals to minus 9, right? Now let's replace d square by minus 9. Then this becomes x into 1 by minus 9 minus 1 into sine 3x minus 2d by, replace this d square by minus 9, we'll get minus 1, minus 9 minus 1 whole square into sine 3x. This becomes x into 1 by minus 9 minus 1 is minus 10 into sine 3x minus 2d by minus 9 minus 1 is minus 10 whole square into sine 3x. This is equals to minus x by 10 sine 3x minus 2d by minus into minus is plus, 10 square is 100 sine 3x. 2 ones are 250s. This is equals to minus x by 10 sine 3x minus 1 by 50 into d of sine 3x. We know that d is a differential operator, so we can replace d by dx. Okay, this becomes minus x by 10 sine 3x minus 1 by 50 into d by dx of sine 3x. This becomes minus x by 10 into sine 3x minus 1 by 50 into derivative of sine 3x is 3 cos 3x. Also we can write this as minus 1 by 10 into x sine 3x minus 3 into 1 by 50 is 3 by 50 into cos 3x, right? So we got result from the first term. Now let's go for the second term. Second term is of 1 by f of d into cos ax form. Then for a equals to 1, we'll find d square, which is given by minus of a square equals to minus of 1 square equals to minus 1, right? Now, if we replace d square by minus 1, the denominator will be non-zero. What happens if we get the denominator 0 by replacing d square by minus 1? We'll just get 1 by 0 into cos x, right? Since 1 by 0 is undefined, so total term becomes undefined. So always remember that the denominator must be non-zero. Okay. So if we replace d squared by minus 1, we'll get minus 1 is minus 2, which is non-zero, right? So we can replace d square by minus 1. Then this becomes 1 by minus 1 into cos x equals to 1 by minus 2 cos x, which is equals to minus 1 by 2 cos x. Or we can write this as minus of 1 by 2 cos x. Therefore, 1 by d square minus 1 into cos x is minus of 1 by 2 cos x. Now coming to yp. Yp becomes, result obtained from the first term is minus of 1 by 10 x sine 3x minus of 3 by 50 cos 3x, and result obtained from the second term is minus of 1 by 2 cos x. So we got our yp, right? Yp and yc. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 e power minus x plus c2 e power x, and yp is minus of 1 by 10 x sine 3x minus of 3 by 50 cos 3x minus of 1 by 2 cos x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.